Hi everyone. So next we are going to learn about the properties of a rhombus and of a square. They have a lot of similar properties, so we always do them together, just like parallelograms and rectangles. I do want to first mention that rhombi, that's the plural of rhombus, and squares are both considered to be parallelograms. So they're both a more specific parallelogram. Therefore, they have all those same parallelogram properties that we talked about last week. So all of these things that are true, opposite sides parallel, opposite sides congruent, consecutive angles supplementary, opposite angles congruent, and diagonals bisect each other. Those are also going to be true for square and rhombus. We're going to do rhombus first. I don't really have any formal notes for this section. So what we're going to do, this is what we would have normally done in school, is I uploaded a copy of this blank rhombus. It's very close to a rhombus, might be tiny, tiny, tiny bit off on the sides, but that's okay. And then the square. And so what I'm going to do is I'm going to draw in the diagonals, actually. Let's draw in the diagonals. And would like you, if you have a printer anyway, I'd like you to do the same. And then I want you to grab your protractor, which you should have one, and your ruler, and I want you to measure all of the angles and all the sides and all these little segments. So if you want to pause it, I'm going to go through and measure all of mine, and then you should do the same, and then we'll talk about what's true. Okay, so this is what you should have gotten, or something very close to this. So what we're going to do is we're going to take a look at the measures that are true, and we're going to take a look at the list of properties, and we're going to check off what's true about a rhombus. Well, I already told you that it was a type of parallelogram, right? So opposite sides are going to be parallel. Opposite sides are congruent. See, these are both 10.2. Those are both 10.2. So yes, opposite sides are congruent. How about all sides congruent? If you take a look at this, all four sides are 10.2 centimeters. So where it says all sides congruent, we're going to check that off too. So, I just realized something. I was checking off square by mistake, but actually it's the same so far. Okay, pretend I didn't do that. So let's go. We're doing rhombus first. I forgot. Sorry about that. Okay, so next are the consecutive angles supplementary. Well, it's a parallelogram, so yes. But if you take a look, the consecutive angles, though, like this whole thing is 120. That's this is also 120. This whole thing is 60. And this whole thing is 60. So remember that the consecutive angles that we're referring to are not like this 60 and 30. It's this whole thing, this entire 120 and this entire 60. So yes, these are consecutive and they are supplementary. Same thing here, 60 and 120, same thing here, same thing here. So all around the shape, yes, the consecutive angles are supplementary. You can check that off. Opposite angles congruent, yes, they are, because see how this is 120 and this is 120. This is 60. This is 60. So that means, yes, opposite angles are congruent. Do the diagonals bisect each other? Well, this was 5.1 centimeters. So was this. This was 8.7. So was this. So yes, these are equal and these are equal, which would mean the diagonals do bisect each other. Are the diagonals congruent? That's the next one. So that was true in a rectangle, remember. Well, if this whole thing is 8.7 plus 8.7, so what's that, 17.4, and this is 10.2, the diagonals are not congruent. So I'm going to leave that one blank. How about diagonals are angle bisectors? This last one. Well, not last one. Almost last one. So that would mean that this diagonal cuts this angle in half and this angle in half. See how these are both 30 and these are both 30, and these are both 60 and these are both 60. So that's not a coincidence. In a rhombus, that's one of the properties that we're going to talk about, is that the diagonals are angle bisectors. So the diagonals always cut the angles in half. So under diagonals or angle bisectors, we're going to check that off. Okay, 4 right angles means the corners, which was not true, right? These were 120, 60. So we're not going to check off that the 4 right angles, the 4 corners are right angles. But lastly, diagonals are perpendicular. Remember, perpendicular means that they intersect to form right angles. So see how this diagonal and this diagonal, they make 4 right angles here. So yes, the diagonals are perpendicular in a rhombus. So if you take a look at that list, comparing parallelogram to rhombus, the only things that are new and different are that all sides are congruent, the diagonals are angle bisectors, and the diagonals are perpendicular. So anytime you have a rhombus, all of these things are true. And so when you're solving problems with a rhombus, you want to set up what you know is true about it based on the properties. So just to show you, these are the problems that you're going to do involving a rhombus. So like, for example, this one, the measure of AEB equals 10x squared. AEB is this angle here. So you want to think about, even like, look at this to compare it. What do I know about this angle here? Well, the diagonals are perpendicular, so I know this is 90, so then you set something up accordingly. Or there's a couple where you have to do a system of equations on this paper. Like notice on this one, in a rhombus, all 4 sides are the same, right? So see how I have x's and y's in both of these sides? So that's how you know you have to do a system. So I can set like this equal to 27 and this equal to 27 because they're both equal to 27, and then you can solve by elimination. So you just need to set up like what you know is true about the picture, basically. That's the same for in all of geometry. Like when you're trying to set up an algebra problem, you just set up an equation to represent what you know is true. This is everything that we know is true about a rhombus. Now, obviously, they're not always going to be 60 and 30, depends on the situation, but the diagonals are angle bisectors. It's always 90 degrees in the middle. All 4 sides are the same. So those are the properties of a rhombus. If you get stuck setting up any of these equations, just let me know. Remember, always label the picture. So like ADN is this one. EAD is this one. Think about how this is 90. Set something up accordingly. Okay, so that's rhombus. Next, we're going to look at squares. So here's our square. So I'd like for you to do the same thing that we just did for rhombus. I want you to connect the vertices, draw on the diagonals, and then measure all the angles and all the segments. So maybe pause the video right now, take a couple minutes to do that, and then we'll talk about what's true. Okay, so let's take a look at all the measures on this square. So notice that in a square, obviously you know that all 4 sides of a square are the same. Notice that 1, 2, 3, 4, all 4 of these little pieces are equal. Again, we have 90-degree angles. Here in the middle, we have each corner is 90 degrees, and notice that they're cut in half. So if we're going to go down this list, I already told you a square is a type of parallelogram. So consecutive angles are supplementary, right? Because like this is 90 and this is 90 and 90 is 180, 90 is 180, 180, 180. So yes, consecutive angles are supplementary. Next is opposite angles are congruent, which yes is true because all 4 angles are congruent, but 90, 90. So yes, opposite angles are still considered to be congruent. Do the diagonals bisect each other? That's next. Notice that the diagonals do cut these 90-degree angles in half to give you 45. Now that's true about every single square. Every square that you're going to be given with the diagonals drawn in, these are all 90, the little ones are all 45 every single time. Because every single time in a square, the corners are 90 and they're cut in half. So a square is always made up of a bunch of 45-degree angles and some 90-degree angles. Are the diagonals congruent? That was not true about a rhombus, but it was true about a rectangle. So let's take a look. Well, all 4 of these little pieces are 10.8, so that would mean that the entire things, yes, they are congruent. So the diagonals are congruent in a square. And I already checked off diagonals bisect each other. I don't know if I talked about that, but these are equal and these are equal. So yes, the diagonals bisect each other. Diagonals are angle bisectors. Yes, because these are all 45. Does it have 4 right angles? Are all 4 corners right angles? So this is 90, 90, 90, 90. So yes. And diagonals are perpendicular. Do they intersect to form 90-degree angles? Yes, they do. So that's also a yes. So notice a square has a lot of properties. So let's talk about the differences between these. Notice that obviously all four of these, parallelograms, rectangles, squares, and rhombi, they all have these same parallelogram features, properties, because rectangles, squares, and rhombi are all types of parallelograms. We had a rectangle where the diagonals were congruent and we had 4 right angles. Notice that these two properties of a rectangle are true about a square. And then notice that these extra properties of a rhombus are also true of a square. A square is special. A square has all the properties of a rectangle, well, obviously parallelogram, and then all of the properties of a rectangle and all of the properties of a rhombus. A square is considered to be a parallelogram, a rectangle, and a rhombus. So it's a specific type of rhombus, a specific type of rectangle, a specific type of parallelogram. So in the web of parallelograms, I'm just going to draw like a quick little graphic organizer flowchart kind of thing. So you have parallelograms. Under the umbrella of parallelograms, there are rectangles and there are rhombi. Now underneath those is a square. So a square is a rectangle, is a rhombus, is a parallelogram. Not all rectangles are squares, not all rhombi are squares, but all squares are considered to be rectangles, rhombi, and parallelograms. Same thing about not all parallelograms are rectangles, not all parallelograms are rhombi, not all parallelograms are squares. So there's that. So squares are pretty easy. So if you take a look at some of these square problems, anytime you're told it's a square, that means you can mark that these are all 45. I mean, you might not need this in every single question, but just in case. So you can mark that these are all 45 and these are all 90 in every square. All the sides are the same in every square. All these little pieces are the same in every square. So this is saying QSR. So then you find where QSR is. QSR is 9x. So this angle is 9x. Well, what do we know about it? We know that 9x is equal to 45 because that's where it was. So you would just write that equation and solve. Same thing for all of these, really. Just label the picture. Make sure you're labeling the picture. So like number 8, SM is 4x, SA is 5x minus 3. Well, what do we know about these pieces? Well, they're equal. And if you forget what you know is true, use these to help you because everything's marked. Or use the chart to help you as well. And so that's really it. I mean, some of these can be kind of tricky just because the algebra on here is tricky, but it's good because you guys really need to practice with your algebra. So I think that's all I needed to go over in the video, but if you have any questions while you're at home, as always, you can email me, or ACLAB is 105 to 155. All right, that's it. Have a great day. I'll see you tomorrow.